With today's rapidly changing need to move to more sustainable design in engineering and manufacturing, I want to review with you the Autodesk Inventor add-in for the Eco Materials Advisor. Based on the material, process selection, and end-of-life choices, Eco Materials Advisor calculates a range of environmental impact measures that can be used to assess the product's impact and to compare and optimize alternative choices. The Eco Materials Advisor is available for download from the Autodesk Application Store. Once downloaded, follow the intuitive installation steps to install onto your system. The Eco Materials Advisor is installed as an Autodesk Inventor add-in and is set to automatically start each time you use the program. To access the command after installed, you will need to go to the Environments tab, Eco Materials Advisor. The Eco Materials Advisor opens in a floating window that can be docked to your Autodesk Inventor interface. At the very top of this window, you do have a toolbar. Two of the main interface options here are the Home button. This will take you to the main interface of the Eco Advisor, and also the View Dashboard. This is where you can analyze your design and view the results in a visual format. To evaluate your part's impact on the environment, you do need to apply materials. You can review the assignments page to review the currently assigned materials to specific parts. You can also explore the materials library and apply materials to your parts in an assembly. You can also search for materials by name or specific property that you're looking for. Optionally, you can assign a manufacturing process to your parts. Each one of these processes does have an environmental impact to the way that you're processing or creating your components. This will also be reported back to you during the analysis phase. When you analyze your design, a range of environmental and cost indicators are evaluated. Energy use, the CO2 footprint, water usage, costs, RoHS compliance, and if the material is food contact compatible. You can analyze the results for parts or assemblies in the Eco Impact dashboard. If you wish, you can change out materials and see how it impacts the results. Or you can create a baseline and compare two iterations of different materials for the same part or assembly. The detail view in the dashboard pane shows a full breakdown of each indicator value for the parts. The highest contribution areas are highlighted in red for the part's environmental impact. Make changes to the parts based upon their environmental impact. Once you change out the material or machining process, the net change will be displayed, either reducing or increasing the part's environmental impact. So we would like a better understanding of the materials in this assembly and their environmental impact, and if there's possible different materials that could reduce that impact. So to do this, we need to go to the Eco Materials Advisor, and I have it docked to the right side right now. And one of the first things we want to do is understand the different materials that have already been applied. To do this, I'll use the View and Edit Assignments. In here, you're going to see the different materials that are assigned to each component. You can also assign a manufacturing process if you want to. That can also help the analysis process and be more accurate. Now, in this particular case, you'll also notice that there's a component that does not have any material already assigned to it. So to resolve that, we can browse our materials database and choose a material. We can search by different physical attributes of the component and find a material, or we could select from a favorites list that maybe we've already created. Now in this case, what I'd like to do is assign this a material that would work pretty well for the exhaust system, And in that case, I think what we want to use is a stainless steel exhaust system. So I'm going to go ahead and assign that to that existing part. And now all the components in this assembly have a material associated with it. And now we can understand the impact to the environment of these components. So when I run this analysis, you'll get some results at the bottom here. You're going to know how much energy it's going to take to generate these components, their CO2 footprint, the amount of water that's required for the processing, a cost, if it's RoHS compliant, if it's a material that could be used in a food industry, and if that component can be recycled, or maybe in some cases, maybe it's a landfill component that cannot be recycled. Now, one of the first things I'm going to do here is make sure that I set a baseline. Okay, so baseline, consider that like 0. This is our current status of all the materials in here. And what we want to do is go in and see if we can adjust these and make the materials a little bit more friendly to the environment. So I'm going to go ahead and go back into my view and edit assignments. And you'll notice in here at the very top we have this engine case. And if we look at the detailed view of this, we can see that obviously it's made of titanium, and the engine case has a pretty big environmental impact at a 4.6. And we also have the engine head that's at a 4.8. So these values are determined by an equation that is listed in the help file. And essentially what it means, the higher the value, the more environmental impact. So you can see these two components have a pretty large footprint as far as the environmental impact, where everything else has a pretty small effect. So let's go ahead and take a look here. So this engine head, I'm going to go ahead and see if we could find an alternative material for this by browsing out and checking our system. And in this case, I think what I want to use is probably a non-ferrous metal, maybe like an aluminum. So aluminum would make a good heat sink material. And I'm going to assign that. You can see I have been placed down in the part level, so I will just return back up to the assembly level. And what I would also like to do is maybe adjust the engine case. Okay, so you can see the engine case, it's got a pretty high value here still. And what we want to do is just dig in, find an alternative value for that. And maybe in this case we're going to use a cast iron component. So I'm going to go ahead and assign that. And let's go back up to our assembly level and just update these values. And you can see it looks like that case change here was a pretty good change. We went down to a 4.5, but you could see that aluminum material, maybe it wasn't such a great choice in this case. It actually bumped it up a little bit. Maybe we should switch that to maybe another material. So let me go in and browse again. And maybe instead of an aluminum alloy, maybe I'll use a stainless steel. And I'm going to go ahead and assign that to the materials. So you can see here pretty dynamically you could get a good understanding of what's happening with these components and how they impact the environment. So you can see pretty big changes there. Things have definitely been reduced a little bit. I like the look of that. Let's go ahead and switch over here and take a look at the environmental impacts. So you can see these changes had a pretty dramatic change to the environmental impacts here. So you can see we're using quite a bit less energy to create these. The CO2 footprint's quite a bit less. The overall cost is definitely less to us. Although this process does use 28% more water in the processing of these components. Now, what you could also do if you want a more detailed report, at the very top, we could view the different reports and you could see the environmental impact report, or we could even do a comparison report between our baseline assembly and the new material that we're using in the next assembly. And this gives you a very detailed look at what goes into this. So you can see basically we're reducing energy by 72%. That's a pretty large reduction. 75% in the CO2 footprint. Although we're using 20% more water, I would say we're looking pretty good on this. We've definitely had less of an impact on the environment, even though our water usage has been increased a little bit. Thank you for watching this M2 Tech Tip. If you have any comments or questions, please contact us.